Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on highest common factor and lowest common multiple. So by the end of this video, I want you to know what HCF and LCM are. I want you to be able to calculate highest common factor and lowest common multiple of two numbers by using factor trees. But before we get to using factor trees, let's go through what they actually are. So we're going to start with two numbers because you have to calculate the lowest common multiple or highest common factor of two or more numbers. So I'll just start with 12 and 20. So on the previous video, we calculated the factors of 12. They're all the numbers that go into 12. So all of these numbers go evenly into 12. Remember, multiples of 12 were all the numbers divisible by 12. To find them, you count up by 12s. And the multiples go on forever. So the multiples of 12, 12, 24, 36, we're going up by 12 each time. Each of these numbers is divisible by 12. So let's now look at 20. Let's look at its factors. Well, 1 is a factor of any whole number. So 2 is a factor because it's even. Now 3 doesn't go into 20, but 4 does, 5 does, and so does 10 and 20. So remember, they come in pairs. 4 times 5 is 20. 2 times 10 is 20. 1 times 20 is 20. So there are all the factors of 20. So now let's look at the multiples of 20. So we're going to find all the numbers divisible by 20. Well, not all of them, just a few. So 20 is divisible by 20. So we go up by 20, 40, 60, 80, 100, and so on. These are all the multiples of 20. Once again, they're going forever. So the highest common factor of 12 and 20 is the highest number that goes into 12 and 20. The highest number that goes into 12 that is also a factor of 20. So we've got all the factors listed here. So the highest number in both lists is 4. So 2 is also a common factor because it goes into 12 and 20, but it's not the highest common factor. The highest number that goes into 12 and also goes into 20 is 4. So we write it like this. This just says exactly what I just said. Highest common factor of 12 and 20 is equal to 4. So now let's look at the lowest common multiple. It is the lowest number divisible by both numbers. So here are numbers divisible by 12. Here are numbers divisible by 20. We want to find the lowest number that is in both lists. The lowest number divisible by 12, that's a multiple of 12, but also a multiple of 20. And so you can hopefully see from this list that that number is 60. So the lowest number divisible by 12 that's also divisible by 20. The lowest number that is a multiple of 12 and also a multiple of 20 is equal to 60. Okay, so this is all well and good, but let's be honest. We don't want to get two numbers and write out all their factors and heaps of their multiples out each time. We want sort of a more definitive way to do that, and we're going to do that now using tree diagrams. So we used factor trees last time. Remember, what you do is you take a number and you write it as the product of primes. So if we write a factor tree for both numbers for which we want to calculate the highest common factor, we do a factor tree for each. All we do is circle the common numbers, multiply them together. That gives us the highest common factor. We just do one extra step to find the lowest common multiple, and that's multiplying the two numbers and dividing by the highest common factor. So that probably doesn't make a lot of sense yet. Let's actually look at the example we just did of 12 and 20, and we should get the same answer. So to calculate highest common factor, lowest common multiple of 12 and 20, we're going to draw a factor tree for 12 and also for 20. So remember how we do this? We just find any factors of 12. So like 4 and 3. 3 is prime, so we stop there. 4 is composite, so we need to factorize it again. 4 is 2 times 2. So now we have only prime numbers at the bottom. So 12, the prime factorization of 12 is 2 times 2 times 3. Now let's do the same for 20. So any factors of 20 will do. So let's try 10 and 2. So once again, 2 is prime. 10, however, is not. So we need to factorize 10. So 10 is 5 times 2. So now 20 is 5 times 2 times 2. These are all prime, so we stop. We've done step 1 and drawn factor trees for both numbers. So step 2 is we circle numbers in both trees. So you can see that there is a 3 in this tree, but not in this tree, so it's not common. Similarly, we have a 5 in this tree, but not this tree. But what is common? What is in both trees? They both have 2 2s. So there's 1 pair of 2s and 2 pairs of 2s. So the highest common factor of 12 and 20, step 3 says we just multiply the numbers that I've circled in red. So the ones I've circled in red, 2 and 2, we just multiply them together. And we get 4, which is the exact same answer we got last time. So how we find the lowest common multiple? So we're just going a step further. So all we do is we multiply the original 2 numbers together, 12 times 20. And that will give us 240, and then we divide this by the highest common factor. So the lowest common multiple is 12 times 20 over 4, which is 60, the same answer we got on the previous slide. All right, I'm going to get rid of this example and do one more. Please pause and copy down if you need. So for this final example, I'm going to calculate the lowest common multiple and highest common factor of 36 and 90. So step 1, I need to draw factor trees for both numbers. So let's start with 36 and draw a factor tree. So any 2 factors of 36 will do, so let's try 9 and 4. So neither 9 nor 4 is prime. They're both composite, so I need to factorize again. 9 is 3 times 3. 4 is 2 times 2. So each of these numbers I've underlined is prime. I've written 36 as some primes multiplied together. So first factor tree done. Now let's move on to 90. So any 2 factors of 90 will do. So let's say we have 45 and 2. So 2 is prime. I can stop there. 45, we should know there's no way it's prime because it's clearly divisible by 5. So it's composite, I need to factorize again. So I can write it as 5 times 9. So 5 is prime, but 9 is not. So I need to keep going and factorize 9. Now I've only got prime numbers. Once again, the numbers underlined are all prime, so my factor tree for 90 is done. 5 times 3 times 3 times 2, that will give me 90. So I am done step 1. So step 2 says I need to circle what's in both trees, what's common. So I can see that there are 2 3s in both, so I can circle these in both trees. Now, there is a 2 in each tree. This tree, however, only has 1 2, whereas this has 2. So I only circle one of the 2s, okay? Because 2 2s, which is like 4, is not common in both trees. They don't both have 2 2s, they both have 1 2, but they don't both have 2 2s. So hopefully that didn't confuse you too much. I'm only circling 1 2. I'm not circling this second one because there wasn't a second 2 over here. So this 2 is by itself, this 5 is by itself because there was no 5 in the tree here. That's why I didn't circle it. So now I've circled what is common to both trees. Step 2's done. Step 3, to find the highest common factor of these 2 numbers, all I do is multiply together the numbers I've circled. So 3 times 3 times 2, which is 18. So 18 is the highest number that goes into 36 and also 90. That wouldn't have been so easy to do without the factor trees. All right, let's now find the lowest common multiple, step 4. So what I do is I multiply together the 2 numbers and I divide by the highest common factor. Now, if you're not allowed to use a calculator, this would be tricky. 36 times 90 is not that easy for people to do in their heads. So here's a trick you can use. What you can do is you can divide the first number by what's on the bottom. So we know 18 goes into itself once and goes into 36 twice. We're sort of simplifying. If we do that, it makes the calculation so much simpler. Instead of doing 36 times 90, getting a big number and dividing by 18, now all we have to do is 2 times 90, because, dividing by 1 doesn't change it. 2 times 90 divided by 1 just gives you 180. That was so much easier to do. Okay, so always try and cancel if you're not using a calculator. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.